Hello all, so the next question, we want to integrate this function over a given domain using cylindrical coordinates. So the first thing, we will try to sketch the region as usual. So answer, step 1. So first let's see what it is. Actually it is representing some annular region and these are straight lines. Okay, and we want to consider everything where in the first, where x is positive. So here if we try to analyze this, so this means the line y equal to 1 by root 3x, and here it means y equal to 3 by root 3x or y equal to root 3x. So we will try to draw this line on the positive side of x-axis. Okay, so the lower line, this line has a slope. If we try to draw this, this is y equal to 1 by root 3x, and the other line is something like this, y equal to root 3x. Okay, so we have to consider everything between these two lines. And next is we what will be the angle. So here we know the angle is always y by x. So from this, what is y by x is 1 by root 3. So when is that is also same as tan x, tan theta. So we can easily see this angle, the lower angle will be pi by 6 and the upper angle will be pi by 3. Okay, so we have this angles. Now the next information, we have circles between two circles. Okay, so everything between these two lines. Next is we draw the circle. So the first circle, something like this, that is of radius 1, and the other circle is of radius square root 3, right? So this is x square plus y square equal to 1, x square plus y square equal to 3. That means the other circle will be something like this. Obviously in the first quadrant only we are looking the positive side of x. So that is circle with radius square root of 3. Alright, so therefore in the base we have this region for integrating. Alright, so this we have to, this type of region, we have to just consider the stack from height z equal to 0 to z is equal to 3. That means we will have something like this. So if we have x and y axis, so we just take a part of the cylinder. Okay, so if we take this entire cylinder, so we will not take the entire cylinder, but we will just take a part of it. Okay, I mean annular part of it. So how are we going to determine the limits here? So we have to assume, we have to use cylindrical coordinate. So again, cylindrical coordinate, we know x is r cos theta always, y is r sin theta, z is z, and the Jacobian without fail is going to be r. Now what will be the limits? So we know that theta is in this cylinder we are not taking the entire thing in the base. We are taking only between these two lines. So the angle, if we see, so pi by 6 less than theta less than pi by 3, that is the angle. And the radius, it's actually it is not the complete cylinder, it is two cylinders enclosed inside it. So if we try to analyze, it is two cylinder and we are just taking part of it. So this region from top to bottom. Okay, so the radius obviously will be from 1 less than r less than square root of 3, and z is already given, we will not touch that. So it is from 0 to z to 3. Alright, so we have the coordinates, we have the limits. Let's try to integrate the function. What is the function? F of x y z is equal to z upon 1 plus x square plus y square, and when x is r cos theta, y is r sin theta, this will be just z upon 1 plus r square. Okay, because r square theta, cos square theta, r square sin square theta, r square comes common, so I'm simply writing it 1 plus r square. So therefore our integration, triple integration f over s, is now equal to triple integration f becomes, as we see, So z by 1 plus r square. So z upon 1 plus r square. Without fail the Jacobian. And then we can take any limit. So we will take d theta, dz, dr. And we know theta is from 0 to 2 pi. Z is from 0 to 3. And sorry, theta is from, sorry, my mistake, pi by 6 to pi by 3. Z is from 0 to 3. And r is from 1 to square root of 3. So 1 to square root of 3. Okay, so this is the conversion. Now we will integrate one by one. So this is 1 to square root of 3. With respect to theta, everything is constant. So 0 to 3 z r upon 1 plus r square is a constant. 0 theta from pi by 6 to pi by 3 d theta and dz dr. Alright, so this will be just integration. This will be just theta with the limit pi by 6 to pi by 3, and that is nothing but pi by 3 minus pi by 6, or simply it is pi by 6. Right, so taking the LCM and all, so pi by 6 I'll just write out, so which is pi by 6, 1 to square root of 3. Next integration is with respect to z, so r is constant, and 0 to 3 z dz dr. Alright, so we can see that this integration is will be equal to z square by 2 from 0 to 3, or simply 9 by 2, right? So that also I take out, so pi by 6 into 9 by 2 integration 1 to square root of 3 r upon 1 plus r square dr. Alright, so for this what we will do, put 1 plus r square is t, that implies r dr is equal to dt by 2, and we have to change the limit. So when r goes to 1, this implies t will go to, if I put r equal to 1 here, t will become 2. So depending on this limit I am taking, and r goes to root 3 implies t will go to root 3 square, that is 3 plus 1, that is 4. Okay, so we are now reduced to, and this also I'll cancel, 3 2 times, 3 3 times. So I am left with 3 pi by 4 integration 2 to 4 dt upon 2t. Alright, so 2 I will take out. So 3 pi by 8, and integration of 1 by t is log of t 2 to 4. So finally this is 3 pi by 8 log 4 minus log 2, and if I take the division, so this is 3 pi by 8 ln of 2. Alright, so that is the final answer. Thank you.